So children, we are going to start electricity, and as you know, there are certain basic parts of electricity. If you can understand that, you can go through the whole chapter very easily. So first of the things and the foremost thing is, let us talk about charges. We know that matter is ultimately made up of atoms, and atoms are made up of three fundamental particles: protons, neutrons and electrons. In electricity, we don't have to do anything with neutrons because neutrons are neutral by nature. They reside in the nucleus. Protons also reside in the nucleus with the neutrons, but protons are positively charged. Each proton carries a charge of 1.6 into 10 to the power minus 19 coulombs. Later on, I will denote the unit of charge coulomb as capital C. So you remember that. So unit of charge is coulombs, which will be denoted by capital C for our further references. Now, the protons and electrons, they have got the same magnitude of charge, but they are opposite in nature. And therefore, protons we put plus sign and electrons we put minus sign, negative sign. And magnitude is 1.6 into 10 to the power minus 19 coulombs. So first and the foremost thing is a small numerical part we have to understand. That is, if I say what is the charge on 10 electrons. So 10 into this, and then finally you place a minus because electrons are negatively charged. If I say what is the charge on 100 protons, if I say what is the charge on 100 protons, then what you will say, 100 protons, so 100 into 1.6 into 10 to the power minus 19 coulombs, and at the front you will put a plus sign. Alright, so that means if we have to calculate charge in coulombs, we have a formula already. Charge in coulombs Q is equal to number of charges into the magnitude of charge, but the sign plus and minus should be placed by you. For example, if a neutral body loses electron, what will happen? It becomes positively charged, because we know neutral bodies contain equal number of protons and electrons, and charged bodies contain unequal number of protons and electrons. In chemistry or in all the places of science, we use the term ions. Cations means positively charged body, and anions means negatively charged atom. Cations positively charged and anions negatively charged. So a positive charged body of course will mean more protons and less electrons. That means it has lost electrons, because protons don't get transferred. So electrons transfer causes the formation of ions. So that means a negatively charged body will contain more electrons, less protons, and so on. So now if they directly ask you what is the charge on 100 electrons, so minus 100 into 1.6 into 10 to the power minus 19 coulombs will be the answer. But suppose I put up a question, what will be the charge? Question number 1 is, what will be the charge? What will be the charge? What will be the charge on a body which has lost 10 to the power 19 electrons? So the solution is simple. What is that? Q is equal to N into E. So this means that Q is equal to 10 to the power 19 into 1.6 into 10 to the power minus 19. That is equal to 1.6, but here there should be plus sign because it has lost electrons. So it will be positive charge. If it would have gained, it would have been negative charge. So this, have you understood? So this Q is equal to N is the formula through which we can get. Now see what happens, the techniques, you have to cross check whether you have understood or not. Whenever a body loses electrons or gains electrons, that means transfer of electron takes place. There are two changes. One is the qualitative change, that means the body either becomes positive charge or negative charge, which you know how it will become. And secondly, how much is the charge? How much will be calculated by this? So just the reverse of this. If I ask you what has to be done, has to be done to give a body 1 coulomb of charge, 1 coulomb of charge, 1 coulomb of charge. So your obvious answer will be, what will be done to give 1 coulomb of positive charge? So your obvious answer will be, if you have to give positive charge, you have to withdraw or take out electrons from the body, and how much electrons have to be taken out, you should be calculating it through the formula Q is equal to NE. So we have to take out N is equal to Q by E, that means 1 by 1.6 into 10 to the power minus 19 electrons. So we can solve it. So 10 by 16 into 10 to the power 19. This goes on 0.625 into, so it will be 625 by 1000, that means 3 zeros less, so 16 electrons has to be removed. So if you take out this many electrons from a body, what will happen? If you take out this many electrons from a body, what will happen? The body will carry unit positive charge. Some children in competitive examination, those who are preparing for competitive examination, they have to keep these numbers in their mind. 1 coulomb of positive charge, take out 625 into 10 to the power 16 electrons. 1 coulomb of negative charge, given this much of electrons. Did you understand? So this is okay. Now, if a body gets charged, how do the body react with each other or interact with each other? Charged bodies, like charges obviously will repel and unlike charges will attract. That means there is a field around the charged bodies. Charged body where its influence is there, it can attract or repel. Theoretically, attraction or repulsion by a charged body to another charged body or anything else, it extends till infinity, but practically it is very close when it starts pulling the charge. So what is electric field then? Later on you will learn elaborate things about this electric field, but at present, for your basic understanding, electric field is all that influence around the vicinity of a charged body up till where its influence can be felt, and theoretically it extends till infinity, but practically it is very close to the charged body. That is what is very, very important, that a charged body will repel the same charged body and will attract. That means if you have to take a positive charged body too near a positive charged body, obviously it won't go. So you have to push, therefore you have to do some work, and as soon as you do some work, something gets stored in the body, a potential gets stored, the body can be able to work. What do I mean to say? Suppose I am a positively charged body and there is another fellow who brought a ball near me, and I am a very, very highly positive charged body, and then he brings a small ball which is positive charge. He pushes, it won't come, it pushes, he leaves it here, the body will go back, the charged body will go back. So that means when somebody is bringing the same charged body near another charged body, already there is a potential being created. And if I am very highly positively charged body, and there is a negative charge there, I am trying to attract it. So already I have created some potential, and that charge, negatively charged body, can come to me provided I provide a path. So there is another more important information I want to give you, a very, very simple and small information, that when we study charge at rest, that means when the charge is not moving, then we give the term electrostatics. We give the term electrostatics. And electrostatics has got a small law that if suppose there are two charged bodies, say for example two same charged bodies separated by a distance r, then for your basic knowledge, you understand Coulomb gave a law. He said that the electrostatic force of attraction between two charge body is directly proportional to the product of the magnitude of charge and is inversely proportional to the square of the distance separating the two bodies, two charges. It's like you can relate it to in ninth what you studied about gravitation and Newton's law of gravitation. It's almost the same equation we get. F is equal to K Q1 Q2 by R square, where K is a constant and K value later on in competitions and all you can be given. K is equal to 1 by 4 pi E0 ER, which is not of much use at present of your level, because I will come to that later, but this is what the Coulomb's law for attraction and repulsion on charge body, Coulomb's law. This is what Coulomb's law says. So this is the first, see, you recognize my video by video 1, so you can connect, just look at this, you will be able to understand. I will give you certain worksheet on this, on numericals on this, and then if you have also understood this part also important, you have understood what is 1 coulomb of positive charge, a body which has lost 625 into 10 to the power 16 electrons. Thanks.